IGCSE Computer Science, Syllabus Statement 1.3.2a, show understanding of the basic von Neumann model for a computer system and the stored program concept. So this is we're pretty much learning about the CPU and how it works. Yeah, that's it. So back in the day, around 1940s, John von Neumann, the guy here, John von Neumann, created a concept. He created the concept of holding programs and data in memory. So then that's pretty much like his idea sort of came together, and we get the CPUs that we have today. Yay! Because before that, like around Turing's time, I think, I'm no good with history, but like the very first computers had to be fed data while the machines were running. So like you couldn't store anything. So yeah, von Neumann came up with this, and here we are now today with cool computers. So let's learn about this. So this is a basic model of the architecture that he thought of. So we get the memory unit, input and output, the processor and control unit. So these are all linked together with these wires here. These are called buses. The red is the address bus, the green is the data bus, and the blue is the control bus. And this is, of course, input and output, which we'll get to. Actually, I might as well explain this now. There's this entire topic on input and output, so that's pretty much where we're going to learn most of it. And then after that, we're going to learn about storage. And once storage is done, we're pretty much finished with hardware for this topic, and we can move on to software. But once we get through storage, hopefully you'll have a basic understanding of how everything works. So, yeah. So basically, what these wires carry is bits, like, you know, data, like everything, like all data is like composed of bits, bytes, so on. So let's look at the buses. So we've got a name, a description, and direction of data or signals for each bus. So the address bus transmits signals relating to the addresses between the processor and memory. And its direction is unidirectional, which basically means that signals travel in one direction. The data bus is, it transmits data between the processor, memory unit, and input and output devices. And it's bidirectional, which means it can travel in both directions. The control bus transmits signals relating to the control of all activities in the computer. So like the read and write operations, which we're going to look at later in this video. And this is actually considered to be unidirectional and bidirectional because of the internal connections in the CPU. So this is a more detailed model of the von Neumann model, and this is basically sort of focuses on data and control, and it's more detailed because we can see more parts and these green things here. Now these green things are called registers, and if you remember from the fourth video, we looked at registers like controlling a washing machine. So we changed the ones and zeros to have different functions to do different functions of the washing machine. Here it's a little bit different. Here we mean a register is a high-speed storage area in a computer. All data has to be stored in a register before it is processed. So they sort of act like a sort of short storage for data, which these parts, of course, use. And we'll get into that, although this might not make sense at first. once we actually get into this later in the video, as well as in the next video, when we look at the fetch execute cycle, this will you'll basically understand this a little bit better, how these parts use the registers. Now keep in mind that I put these registers here, but these don't illustrate, like, I mean, they doesn't mean that the registers are necessarily there in that location. I'm basically trying to illustrate which parts use the registers, and we'll see that right now. So let's look at the memory unit. So the memory unit makes use of the MAR and MDR registers, which of course stand for these. The memory unit is made up of partitions, and each partition has an address and the address's contents, which we'll see right now. So say the address was 00000000, contents would be 11001010, and of course the contents can be anything. The contents basically the data. Now keep in mind that computers, like the CPU, is pretty, like, it has quite a number of addresses. So this is just to illustrate, because just to illustrate how locations and contents work. So the addresses in the CPU, first of all, we'd have a lot more. And second of all, they wouldn't all just be 8-bit. Like, they'd be pretty big, like quite a lot. We pretty much get quite a lot of them. So this is just to illustrate what we mean. Now these arrows here basically mean that these are continuing until we get to 11111111. So there are quite a few in between this and this. So how are the registers actually used with the memory unit? Well, let's look at the read operation. So what happens is, for example, if we want to read the contents in this location right here, we want to read these. The address is written to the MAR. A read signal is sent to the memory unit via the control bus. The contents of this memory are written to the MDR. So the MAR would look like this, the MDR would look like this. So basically the MAR holds the address, that's why it's called the memory address register, holds the address, and the MDR, the memory data register, holds the data of the address. So we look at the address here, the contents would be 11001011. So it's what the MDR would hold. So let's look at the write operation. So say we want to write this to location 11111101, which is right here. So we want to replace this value with this value. So the contents are written to the MDR, so the data written to the MDR. The address is written to the MAR, and a write signal is sent to the memory unit via the control bus to make this happen. So the MAR would contain the address, and of course the MDR would contain the data. So if you remember this table here, and this location right here, the address and the contents, well, we're going to replace that with the new contents. The reason I'm showing you this is because there's one exam question which said show the changes that have been made to the memory unit. So basically, this is what you have to do is to fill in what has been changed. So this has been changed right here. What I was actually thinking about is after the end of the series, as in after I'm done with paper 2, I was thinking of looking at an exam paper just as an example to show you how questions should be answered. Because, like, some people may lose marks for what they don't say. But yeah, it's quite, like, there's quite a lot of information you need to know for the theory paper especially, so it's good if we get some practice with that. So let's look at the processor. The processor contains the ALU, the arithmetic and logic unit. The ALU is used for math operations, so like add, subtract, multiply, divide, and logic operations, such as AND, OR, XOR, and NOT. Now, the ALU makes use of a register called the accumulator, which stores the results of its calculations. So yeah, it's another register that you need to know, which is which was the ACC at the top of the processor, the accumulator. The control unit this is the last thing we have to look at in this video. The control unit makes use of the CIR and the PC. And now we'll look at these two. We looked at the MAR and MDR in quite a bit of detail, but we're actually going to look at the CIR and PC in the next video when we look at the fetch execute cycle. So the control unit controls the operation of the CPU. It reads an instruction from memory, so the address of the instruction is stored in the PC. This instruction is interpreted and signals are transferred via the control bus to tell other components what to do. So that's pretty much how the control unit works in a nutshell. If you're still confused about how this works, watch the next video once it comes out, probably out now, depending on how long this video has been out. And that should pretty much explain the entire process of how everything works in a CPU. So this video is more of the the actual the actual model and how transfer and stuff works, but the next video should explain it in a little bit more detail. Now, the input and output devices, just as a side note, is a whole separate topic. I think I said that at the beginning of the video. And yeah, once we get to that, you'll hopefully understand how input and output works along with the CPU. Although it's more of the devices and not the actual... Oh, well, never mind. Yeah.